Looking at the 3's, I'm going to explain 3A. I'm not going to work out 3A for you. I want you to work out 3A. Question asks, which of the following gases would have the greatest or the highest density at STP? Now, STP, that I may or may not have mentioned in class, is a special set of conditions which we'll talk about next time that we discuss or have a lecture. But conditions at STP, this represents standard temperature and pressure. And what that means is the temperature at this set of conditions is that the temperature is at 273 Kelvin, or 0 degrees Celsius. And the pressure is at 1 atmosphere. Okay? So that is what STP means. I will allow you to solve for the density in each case. So what I'd like for you to do is, probably the best way to do it, find the molar mass of this and then plug it into your equation, which will be very similar to some of the examples that I'll do here in a moment. But the discussion we haven't had is about STP. So if you're not sure what STP is, these are the conditions for STP. All right, so let's look at 3B. I'm going to blow that just a little bit. Okay. All right, so 3B asks for you to calculate the density. So we're looking for the density here. And again, density is mass over volume. So those are the variables that we care about. Sulfur dioxide, so that's kind of important because we have a compound, sulfur dioxide, di meaning 2. Gas in grams per liter. So this is just a clarification that we're going to have our units in grams per liter, which will be the case for a lot of these problems. At 20 degrees, so at 273, which means we have 293 Kelvin, and at a pressure of 1.33 atmospheres. Okay? So what we need to do is ask ourselves, well, we need to find density. So we'll use the equation, PV equals nRT. And again, this will be the equation that I'm giving you, and you have to be able to work with that. However, do realize that I discussed earlier today that there is a substitution that you can put in place for N, which again is little m over big M. And be mindful that we're working with gases. Now, in AP Chemistry, we will talk about big M in terms of molarity for gases, but for honors, we're going to leave it as molar mass. So the little m represents mass, which is in grams. The big M represents molar mass, which is in grams per mole. So if I take grams divided by grams, and again, not a big fan of having, say, moles down here, double division lines, just don't like that. If I take the moles and put it where it should be and get rid of that second division line, because again, moles is going to be on the opposite side of the grams, what happens to the unit grams? They cancel off. We're left with moles, which is equal to N. So the molar mass, make sure you know your units, grams over moles, which we've been doing, so it's not something that's new. And then the mass generally will be given to you in the problem. Okay. All right, so I want to substitute that in. So now my equation is going to look like this. PV equals little m over big M, RT. Now, remember that we're looking for the density. So the variables that we're trying to get are little m over V. All right. So I want to rearrange so I can get those variables by themselves. Since little m's already there, let's not touch it. So I'm going to start off by dividing by volume on both sides. And again, this is going to be a stepwise progression here. So now I've got P equals little m RT divided by big M and V. All right. So that's what's happened. I've taken the volume, divided it on both sides. Now I have this equation. Right now I'm happy because I have my moles, my mass and my volume where they need to be. So I'm going to move molar mass out of the way. So I'm going to multiply it on both sides. And I'm also going to divide by the R and T on both sides. So again, multiply molar mass on both sides. So that means it moves up. Divide RT on both sides, so it moves down. So now my equation looks like this, where I have PM over RT is equal to little m over V. And that's what happens. The RT divides the big M, multiplies on both sides. We're left with our density units. So now we have this in place. And the units are going to help us. They're going to tell us that we did this right. So let's go ahead and actually scoot that down a little more. Okay. So I'm going to take these and plug in my values. So in this case, my pressure, 1.33 atmospheres. My molar mass is SO2, which I've yet to calculate. So I need to do that. So SO2, so sulfur is 32.06 grams. You get that from the periodic table. I have 2 oxygens, 2 times 16, which is 32. So 32 plus 32 is, that's right, 64. So the molar mass is, I'll do it this way. Yeah, I'll do it that way. 64.06 grams. I'm going to put moles right below it. So the molar mass, and we have to show this. Oops, let's use a different color there. So we have to show this. So it's grams per mole. That's the molar mass. All right. Now I have my R. Which R should I use? Very good. So I have ATM, so I want to use the atmosphere one. So 821 atmosphere liter. I'm going to put the mole Kelvin over here. Now notice how I'm using the same colors here to help identify that's the R, that's the molar mass, so it gives you an idea. And then temperature's 293 Kelvin. Now, let's cancel out alike terms. So the atmospheres go away, my moles go away, my Kelvin goes away, and I believe that is all that can go away. So now I have grams per liter, which is the unit that I should have, because that is density. And let's plug that in. Give me 3.55. 3.55 is my density. Okay. Let's take a look at the next one. Okay, so the question asks, if 35.23 grams, that looks like a mass to me, of a gas occupies a volume of 23.2 at a pressure of 3.5 atmospheres and a temperature, which we'll add that to, so we got 329 Kelvin. What is the molecular mass, that is big M, of the gas? Okay. So here we're looking for the molar mass. So let's start off again with PV equals, that's an N, sorry. PV equals nRT. And let's substitute again the little m. So now we have PV equals little m over big M RT. And this time I'm looking for big M, only big M. So I'm going to make sure that is in the numerator. So I'm going to multiply that on both sides. Also, I want to get that all by itself, so that means I'm going to divide by P and V. So now my equation looks like this. I have big M is equal to little m RT divided by P and V. Okay. So again, what I did was I multiplied by big M on both sides, divided by PV on both sides. From here, just plug and chug. Isn't it fun to just take your values and plug them in? So we've got our mass, which is 35.23 grams. The R, do I have a pressure here? Which is an atmosphere, so I'm going to use my atmosphere. So 0.0821 mole Kelvin. My temperature, 329, and my pressure, 3.5 atmospheres. And my volume is 23.2. So let's cancel out alike terms. It's like atmospheres, Kelvin, or liter. We're left with grams per mole, which is molar mass. All right, let's get a number there. And my molar mass is like 11.7. And that's grams per mole. Okay? Now let's take a look at that one. And I'll also show you the other one here in a moment. Let's actually extend that a little bit. Okay. And then the first problem, sorry I didn't show you that the first time, looked like that.